Okay, session number 11, the last article from numerical method, that is numerical solution of ordinary differential equation. Anyone knows what is ordinary differential equation? Is there anyone knows what is ODE there?
No, sir.
No. Ordinary differential equation is the equation where ordinary differential coefficient exists, like dy by dx. Okay, and there's another is PDE. So we'll come to the detail in that. So first I will tell you the today's agenda. So today, first we'll see why there is a need of numerical solution of ODE, and then out of the three methods that we have in our syllabus, Picards, Euler's, and Runge-Kutta will complete Picards method to solve ODE there. Okay. So let me start with first why there is a need to solve the why there is a need of this numerical method to solve the ODE. I will show you one simple example of ordinary differential equation. This is the ordinary differential equation. General form of the ODE, just a minute. General form of the ODE, is it visible? Check. Dy by dx is equal to f of xy. Okay, so this is the general form. Dy by dx is equal to some function of xy. So whenever we have the ODE, few ODEs can be solved by direct method. What is a direct method? One of the simplest method that you learnt in your 11th and 12th. Yes, anyone? That is a integrating. So it can be written in a variable separable form. Say dy is equal to x dx, and now integration of dy is y, while integration of x dx is x square by 2 plus c. Okay, so this way. So this is the exact solution of that differential equation, or it is a general solution of the differential equation. When we say y is equal to fx, y is equal to fx is a solution of a differential equation, it means this function y equal to fx satisfies that differential equation. Satisfies that differential equation. That is the meaning of solving the differential equation. So whenever we have to solve the ordinary differential equation, our aim is to get a function y equal to fx that satisfies that equation, differential equation. But not necessary every time this integration is possible. Not necessary every time that uh, integration is simple to evaluate. Right now, just we have to integrate x, and we know the integration of x is x square by 2. But suppose we come across this situation, dy by dx equal to 2 plus root of xy, square root of xy. Now, yes, I'm not saying this is impossible to evaluate, but it is difficult to integrate now. Okay, because we cannot write in variable separable form first. Okay, it's not possible, and then we have to go for few different methods there, and we may get a solution there, but direct solution or exact solution becomes a difficult. So there is a need of this numerical method. We already learned this thing. We started with algebraic equation also, solving the roots of algebraic equation. We seen that bisection, regular falsi, or Newton-Raphson. Not only that, we seen the last article, that is numerical integration. In all these, whenever it is direct method fails, when direct method fails, generally the numerical methods are preferred. Why it is we said numerical methods are preferred? Because numerical method never gives us an exact solution. They always gives us an approximate solution. Okay, with a desired accuracy. Okay, so if we are interested to get solution which is near to the exact, then we use a numerical method there. So this type of a question generally we solve by a numerical method there. I hope you understood the need of numerical solution of ODE there. Is that clear?
Yes, sir.
Okay, good. Thank you. Now, throughout this last article that we have, which is solving the ODE, we always solve the initial value problem. In numerical method, we always have the initial value problem, IVP. So some initial condition is given. Because of that, that problem is known as an initial value problem. What is the initial value problem? So we are going to solve dy by dx equal to f of xy. Throughout the topic, we solve dy by dx equal to f of xy with initial condition. This is the initial condition. Y of x0 is y0. What is the meaning of that? When x is x0, when x is x0, the value of y is y0. That is the initial condition, initial value condition, or sorry, initial condition. So the problem is known as IVP, initial value problem. So in that, generally we find out a solution at some particular point. Okay. Now there are three methods that you will have. One is a Picards, Euler's, and Runge-Kutta. So the first method that we have is a Picards method. In Picards method, we get a solution y equal to fx. Y equal to fx. That means we get a general solution. So this general solution we get in a Picards method only. But in Euler's and Runge-Kutta method, we only get direct solution at x equal to xn. Okay, so Euler's and Runge-Kutta method doesn't provide us a general solution. Only Picards provides a general solution, and then if we want the value of y equal to fx at x equal to xn, we replace x by xn. We replace x by xn, and we get f of xn. F of xn as a final answer there. We'll discuss these things in detail with each method there. Okay. So come to our first method here. The first method, already I said, is a Picards method that we have. So the Picards method, we use it to solve dy by dx equal to f of xy given y of x0 equal to y0. That is the nature of the problem, where we use a Picards iteration formula. The iteration formula for Picards method is the iteration formula for Picards method is yn is equal to y0 plus integration x0 to x f of x yn minus 1 dx there. Okay, this is the iteration formula of a Picards. Clear? We'll not go in the derivation. The derivation is actually really simple. If you want, you can go through the textbook, and derivation will not come in the exam. You should know the iteration formula to uh, get the iterations of the Picards here. Okay. So first important thing, remember this formula, and just a minute, is the last lines are visible? No, I think okay, no issue. Remember, there are two things in Picards method. The accuracy of a solution, increases with the number of iteration. If we take more number of iteration, we get better and better solution there, which is more closer to the exact there. But many times this integration, whatever the integration you observe on the right side there, so this is impossible to evaluate. This is impossible to evaluate, or it is a difficult to evaluate. That time we have to stop the iteration. Clear? Is that clear?
Yes, sir.
So let me see. There are two things. One thing, yes, obviously, if you take more number of iteration, the accuracy increases there. That is always there in numerical method. But many times you observe this integration here. This integration many times becomes difficult to evaluate. Okay, difficult to evaluate or impossible to evaluate. That time we can say we stop the iteration and we take whatever the previous iteration we integrated, that is our final solution. Got it?
Yes.
By example it becomes more clear. When we see the example, it becomes more clear there. Okay, come to the questions now. Two simple questions. The questions are really simple here. First, read a question. Use a Picards method of successive approximation to obtain the solution up to fifth approximation. So which value we have to calculate then? Fifth approximation means y5.
Y5.
Yeah, good, correct. Y5. And we are given dy by dx equal to y plus x. Now can you tell me what is f of xy here then? What is f of xy? Compare with the general problem. What is the general problem? The general problem is dy by dx equal to
Y plus X.
f of xy. Yeah. So f of xy should be this y plus x. So you see, the question is find y5. So the first part we have to find out y5, fifth approximation. Then f of xy we are given, this f of xy we are given as y plus x. What is this y equal to 1 and x 0? Y is 1 and x 0. What are these values? In standard notation, I will write a general problem, dy by dx equal to f of xy, given y of x 0 is y 0 and find the value at xn. So these are the things we have. So what is this y is 1 and x is 0 in this notation? Quick.
So x naught and y naught.
Yeah, correct. That is the initial values we are given. So the problem is initial value problem. So what are the initial values? X0, Y0. So what is X0? X0 is a 0, Y0 is 1. X0 is a 0, Y0 is 1. So these values are initial values, and we have to find out at the end the value of y at x equal to 1, that is xn. So xn is given as 1. So this is the problem. So you should understand first problem there. Now come to the formula. The formula for Picards method, the Picards formula is this one. Yn is equal to y0 plus integration x0 to x f of x yn minus 1 dx. So can you tell me the value of f of x yn minus 1? What is the value? F of x comma yn minus 1. What is the general value here? Here is f of xy. This is f of xy. So what should be f of x comma yn minus 1? If this is f of xy, f of xy is y plus x. What should be f of x comma yn minus 1?
Yn minus 1
y
plus
n minus 1 plus x.
Correct. That's one only. So you'll observe. So next step, just we replace the value of f of x and y, x comma yn minus 1. It is yn minus 1 plus x. Now what should be y1 then? Now tell me y1. y1 equal to y0 plus integration x0 to x. We replace n by 1, na?
Yes, sir.
It is a y0 plus x.
Y0.
Now we have the values here. What is y0 given?
1.
1. Correct. So here is y0. Y0 is 1. So this is 1. What is x0 given?
0. 0.
Y0 is 1. Now just integrate it. So this is 1. What is the integration of 1 plus x?
X plus x square by 2.
Correct. And the limits are 0 to x. If you put the limit, then also the terms become 1 plus x square by 2. What is this final term 1 plus x square by 2? Actually, this is the solution of the differential equation after first approximation. After first approximation, the solution of the differential equation by Picard is 1 plus x square by 2. That is the end of the first approximation. But the question is find 5 approximation. So you have to repeat this process 5 times there. Okay, 5 times. Now we have to calculate y2. So obviously y2 will depend on y1, y3 will depend on y2, and so on there. Is it clear? Any doubt up to here? Is there a doubt in getting y1 here?
No, sir.
No. Okay. So I will show you this calculation here. So y1 will come same, that 1 plus x square by 2, the same thing that is shown here. Now we'll write a formula for y2. Tell me, what should be y2?
Y1 plus integration limits x0 to x.
No, it is not
bracket.
y1. My mistake. So y2 is equal to y1 plus. No, it is y0 is always fixed there. Y0 plus. What it?
Okay, sir.
Integration x0 to x. It is a y1 plus x. So this y0, yes, 1. It is a 0. X. Y1 value is 1 plus x square by 2 plus x dx. And now this x plus x can be written as a 2x and then integration, and you will get the answer. So integration of 1 is x, integral of 2x is x square, integration of x square by 2 is x cube by 6. That's one. Got it?
Yes, sir.
So this is y2. So this way, actually you have to just integrate one by one. You will observe this is your 1 plus x square plus x cube by 6. That is y2. Similarly, you get y3. Y3 depends on y2. Then you get y4, and lastly the y5. So this is just term by term calculation. You have to go iteration by iteration. Every next iteration depends on its previous iteration. So y5 is now whatever this RHS you observed here. This is actually the approximate solution of the differential equation after fifth approximation. That is the end of the first part. Okay, up to here. Any doubt up to here? Is there any doubt?
No, sir. One second, we are writing.
This PPT is already shared me. No? I already shared right now. There is one more part in this question. Hence, find the approximate value of y at x equal to 1. Now, how to get the value of y when x is 1? How to get this approximate value of y when x is 1? Quick.
So we'll put x as equals to
1,
1
yeah,
and y
correct.
prime.
It's 1.
Very good. So just replace x by 1 in that y5. So you get 1 plus 1 plus 1 plus 1 by 3 plus 1 by 12 plus 1 by 60 plus 1 by 720. And you have to do this calculation on calculator. So the answer will come, you will observe y equal to 3.4347 at x equal to 1. Okay. Generally, you should write the answer up to maximum up to 4 decimal there. Minimum 2 decimal should be there. Minimum 2 decimal and maximum 4 is enough there. Got it?
Yes, sir.
So see, the questions are really simple based on the formula. Mainly, what is the most important thing here is this formula. This formula you should be able to recall. And then you can just start with the y1, y2, y3, y4, y5, and so on. There. So in the question itself, it is told 5 approximation we have to do it. That's okay. One last question on Picards here. The question is now find the value of y. Find the value of y at x equal to 0.1. Okay. Use the Picards method. Given that dy by dx is y minus x upon y plus x, and y of 0 is 1. Y of 0 is 1. Now tell me all important things. What is these things in notation? So first I want f of xy. What is f of xy here?
Or y minus x
Y
upon
minus x upon
Correct.
y plus
So the first thing f of xy is this one. Y minus x upon y plus x. Good. What is x0?
0,
Yes, good. X0 is a 0 here. That is correct. And what is y0?
1.
1,
1. That is correct. So this is x0. This is a y0. And what is xn? Where we have to compute at the end.
0.1.
0.1. Correct. This is xn. Now, how many iterations should we do? How many iterations should we do? Y1, y2, y3. How many yn we should calculate there? That's not known. That is not given. Not given in the question. So how to stop then? How to stop the iteration?
until the calculation is going
Whenever
done.
the integration becomes a difficult to evaluate. But whenever this condition comes, don't say that I cannot integrate y1 itself. At least one integration is always possible there. Okay, remember, at least one integration is always possible. Otherwise, you can say y1 itself not possible, then you will not get any approximate solution there. Okay, so generally, you are given those examples whose at least y1 is possible. So we'll start here. Start with the formula. Tell me what is the formula for y1?
Y1 is equal to y0 plus integration limits x0 to x
Uh,
bracket y0 plus x dx.
okay. Y0. No, not y0 plus x. Why y0 plus x always? Huh? That is for previous question. This is not always y0. This is the silly mistake that many students do. They think that y0 plus x is only the formula.
Yes, sir,
That
yes,
okay.
about it. Right.
So
Huh.
got it. Okay. Now y0. What is y0 here? 1. Limit of it is 0 to x. What is the f of x comma y0 now? Tell me. F of x comma y0 value.
1 plus x.
1 minus x upon 1 plus x, is it? 1 minus x upon 1 plus x. Got it? because it is y0 minus x upon y0 plus x. Value of
Yes,
y0
sir.
is 1. Okay. Any doubt up to here?
No, sir.
Now tell me the integration. How will you integrate? Only Picards method require integration. Okay. Other methods are without integration. You can do it. Tell me how you can integrate this.
Sir, +1 and -1 in the numerator.
If you take +1 and -1 in the numerator, you will get 2 minus x, and there's no use of +1 and -1. No? Always adjustment is done with a constant, that is correct, but you should do one thing. If I take minus of 1 plus x as a numerator, I'm taking minus of 1 plus x as a numerator. Why I taken minus there? Because now you'll observe, if you take here -1 minus x is there. This is -1 minus x is there. So minus x is already there, but here is a -1. So what should be the adjusted term here? Is
+2.
it? Is it? So this is the adjustment you should think. You should think for the adjustment so that you can take a separated division. Now you will observe this will come as 1 plus 0 to x. The numerator becomes okay. The numerator becomes -1 plus 2 upon 1 plus x. Is it okay? Now can you integrate this? Can you
Yes, sir.
integrate this?
Yes, sir.
What is the integration of -1 here?
Minus x.
And what is the
Yes,
integration
yes.
of 2 times log of 1 plus x? Is it?
Log of minus x.
So minus x. So the answer will come as 1 minus x plus 2 times log of 1 plus x. So that will be your value of y1 after means that is the first iteration indirectly. Let I show you here in short. So here is the first. So whatever y1 we used by Picards, 1 plus 0. Okay, y0 minus x upon y0 plus x, that way. This is the y1 you should get it. Okay.
Yes, sir.
But now you think about y2 now. If you think about y2, y2 will look like this by the formula. y2 is equal to y0 plus integration that x0 to x f of x comma y1. So this y1 minus x upon y1 plus x will be look like this. Now, can you integrate this? You may integrate, but it is very difficult to evaluate. Is it?
Very complex, sir.
Complex.
Very
So
complex.
better we should stop the iteration. Better we should stop the iteration. We should write like this, which is a very difficult to integrate. Which is very difficult to integrate. Hence, the approximate solution after first iteration is y equal to 1 minus x plus 2 times log of 1 plus x, which is y1 only. So this y1 only is the approximate solution, you can say, after first iteration. And then we want y, a value of y at 0.1. So replace that x by 0.1 here. With the help of calculator, you can get this as answer. Okay. 0.9828 is the answer after first uh, by first approximation only. Is it clear?
Yes, sir.
So that about our first method, Picards method. For Picards method, the prerequisite is obviously the integration. You should know the integration of basic integration that you learnt in 12th mainly, simple single integral again. And you may require the integration of algebraic, exponential, and product rule, or sometimes small adjustment methods. Okay, that things you require. So, but really, the Picards method is a very simple method. All the numerical methods are simple there. The purpose is that only because direct method become complicated or lengthy. Because of that, the numerical methods preferred, which are generally simple to evaluate than the direct method. So because of that, you are learning these numerical methods there. That is main purpose of a numerical there.